Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are on the topic surds. In the previous video, we looked at properties of surds and we also saw how to reduce surds to its basic form. In this video, we are going to see how we can add surds. So, addition of surds. When adding surds, remember that two surds can only be added if the terms under the square root sign are the same. So before you can add two surds, you must make sure that the terms under the square root sign or the numbers under the square root sign are the same. And if you are adding two surds, so for example, if you are adding the surd a square root of b to c square root of b, so you can see from here that the terms under the square root sign are the same. So here we have square root of b, here also have square root of b. Now if you have this, then you can go ahead and add the surd. When you are adding, we add what is in front of the square root sign. So we add a to c, then square root of one of the terms, so square root of b. So we add what is in front of the square root sign, then we pick one of the terms under the square root sign. So a plus c, then square root of b. Remember that the terms under the square root sign must be the same. So here we have square root of b, here we have square root of b. If they are different, you can't add them. Let's pick some examples and see how this is done. So we are told to add the following, leaving our answers in surd form. So you pick these one after the other and solve it. So for the first example, we have square root of 24 plus square root of 96. Now, if you have it in this way, what you have to do is that you have to first reduce these surds to its basic form, then you add. In the previous video, we saw how to reduce a surd to its basic form. We are going to continue with the explanation in this video too. So, if you want to reduce this surd to its basic form, you saw that you have to find two factors of this number, and one of those factors must be a perfect square. Then you find two factors of this number that when you multiply, you are going to get 96. One of those factors must be a perfect square. I showed you how to use the calculator to find that, and I'm going to do that once again in this video too. So first, we need to reduce square root of 24 to its basic form. Then we reduce square root of 96 to its basic form. So let's begin with 24. So you pick your calculator, then you point square root of 24 on the calculator. Now we are having 2 root 6. So the calculator is giving us 2 root 6. So the calculator is giving us 2 root 6. So you can see that the first or the perfect square that you are looking for is the square of the number in front of the square root sign. So the perfect square in this case is 2 squared. Then times the other number will be the one under the square root sign, which is 6. We know that 2 squared is the same as 4. So for square root of 24, you are going to have 4 times 6 to replace 24 here. Then let's do that for 96. So for 96, you press square root of 96. 96. The calculator is giving us 4 root 6. So the first number that you are looking for, the perfect square, is square root of 4, which is the number in front of the square root. Sorry, the square of 4, which is the number in front of the square root sign. So 4 squared will give us 16. Then the other number is 6. So you are going to have 16 times 6. So to reduce square root of 24 and square root of 96, we know that square root of 24 will give us 4 times 6, as we saw here. So we have square root of 4 times 6, as we have seen here, then plus for 96, if you are reducing it, you are going to get 16 times 6. I've shown you how to use the calculator to get these two numbers. Then you proceed from here. From the properties of surds, we know that square root of 4 times 6 can also be written as square root of 4 times square root of 6. We have the addition sign here, so you bring it plus Square root of 16 times square root of 6 as we have here. Square root of 4. 4 is a perfect square, so square root of 4 will give us 2. We multiply 2 by square root of 6 and we are getting 2 root 6. Then plus square root of 16 will give us 4. You multiply that by square root of 6, we are getting 4 root 6. So you can see from here that we have reduced this to the basic form. Now we have the terms under the square root sign to be the same. So when you come here, we have square root of 6. When you come here, we have square root of 6. It means that we can add what is in front of the square root signs. So if you are proceeding, it's going to be 2 plus 4, then square root of 6. You know that 2 plus 4 will give us 6. So we have 6 root 6. Now, you can use your calculator to check if your answer is correct. All you need to do is to press square root of 24. Then you press this sign to remove the cursor from the square root sign. Then you press plus square root of 96 on your calculator. Then you press equal to, and your calculator is giving you 6 root 6 as we have here. Let's pick the next example. We have square root of 32 plus square root of 128 plus square root of 50. So once again, you press this on your calculator to give you the two numbers. So let's do it for this one too. So you press square root of 32 on your calculator. Square root of 32 is giving us 4 root 2. So the perfect square you are looking for is 4 squared, which is 16. Then the other number will be 2. So you have 16 times 2 for 32. For 128, you press square root of 128. Then you press equal to, you are getting 8 root 2. So the perfect square you are looking for is 8 squared, which will give you 64. Then the other number is 2. So you have 64 times 2 for 128. Then for square root of 50, the calculator is giving us 5 root 2. So the perfect square we are looking for is 5 squared, which is 25. The other number is 2. So for 50 is going to, we are going to have 25 times 2. So that is what we have here. We have 16 times 2 for 32. Then we have 64 times 2 for 128. We have 25 times 2 for 50. Then, if we are reducing this, this will give us square root of 16 times square root of 2 plus square root of 64 times square root of 2 plus square root of 25 times square root of 2. Square root of 16 is 4. 4 times square root of 2 give us 4 root 2 plus square root of 64 is 8. 8 times 2, square root of 2 give us 8 root 2. Then plus square root of 25 is 5. 5 times square root of 2 give us 5 root 2. So we can see from here that the terms under the square root sign are all the same. So we have square root of 2 here, we have square root of 2 here, we have square root of 2 here. So we can go ahead and add the terms in front of the square root sign. So 4 plus 8 plus 5 square root of 2. 4 plus 8 plus 5 will give us 17. So we have 17 root 2. So 4 plus 8 will give us 12. 12 plus 5 will give us 17. So we have 17 root 2. Let's pick the next example. We have 3 square root of 8 plus 3 square root of 200 plus 2 over 3 square root of 162. So here too, let's try this on the calculator and see. So once again, you tackle what is under the square root sign. So here we change square root of 8 to its basic form. We change square root of 200 to its basic form. We change square root of 162 to its basic form. So for square root of 8, we punch that on the calculator and we are having 2 root 2. So the perfect square we are looking for is 2 squared. So 2 squared, then the other number is 2. We know that 2 squared is 4. So you have 4 times 2 for 8. For 200, square root of 200, we are having 10 root 2. So the perfect squared is 10 squared. We know that 10 squared is 100. Then the other number is 2. So 100 times 2 for 200. Then for 162, we punch 162 on the calculator. And we are getting 9 root 2. The perfect square we are looking for is 9 squared, which is 81. then times the other number, which is 2. So 81 times 2 for 162. So you replace that with what you have here, as we can see from here. So we are going to have, don't forget that 3 is already in front of the square root sign. So we have 3, then square root of 8 is now 4 times 2, then plus 3 is already here. So we have 3, then 200 will give us 100 times 2 plus 2 over 3 is already here. So 2 over 3, then square root of 162, as we have seen, is now 81 times 2. So from the properties, we know that this will be the same as 3 is already there. Now 3 is multiplying the whole of this. So 3 times, then square root of 4 times square root of 2. You break this down, then plus, we already have 3 here. So 3 times, you break this one also down, square root of 100 times square root of 2 plus 2 over 3 is already here. So times, then you break this down, square root of 81 times square root of 2. Now let's proceed. We have 3 times square root of 4 is 2. So 3 times 2 times square root of 2 plus 3 times square root of 100 is 10. So 10 times square root of 2, then plus 2 over 3 times square root of 81 is 9 times square root of 2. So we proceed. We have 3 times 2 to give us 6 times square root of 2. We have that here. So plus 3 times 3 will give us 30 times square root of 2 plus 2 over 3 times 9 will give us 6, because 3 will cancel itself 1 and cancel 9 3 times. So this is what we mean. So 3 here will cancel itself 1, cancel 9 3 times. So we have 2 times 3 to give us 6, as we have. So 6 times square root of 2. Then we proceed with our simplification. We know that 6 times square root of 2 will give us 6 root 2. 30 times square root of 2 will give us 30 root 2. 6 times square root of 2 will give us 6 root 2. So we can see from here that all the terms under the square root signs are the same. So we can add the numbers in front. So we have 6 plus 30 plus 6, then square root of 2. This will give us 42 root 2. Sorry. Let's pick the next example. We have square root of 80 plus square root of 28 plus square root of 20 plus square root of 63. So you reduce these to its basic form, then you add. So let's look at square root of 80. We are reducing it to its basic form. You press it on the calculator. The calculator is giving us 4 root 5. So the perfect square we are looking for is 4 squared. 4 squared is 16. The other number is 5. So 80 will be replaced with 16 times 5. Then square root of 28 will give us 2 root 7. So the perfect square we are looking for is 2 squared, which is 4. The other number is 7. So we have 4 times 7 to replace 28. Square root of 20 will give us 2 root 5. So the perfect square we are looking for is 4. Since we will have 2 squared, which is 4, then the other number is 5. So 4 times 5 to replace 20. Then square root of 63 will give us 3 root 7. So the perfect square we are looking for is 3 squared, which is 9. Then the other number is 7. So 63 will be replaced with 9 times 7. Then you proceed and simplify. So 80 will give us 64 times 5, 16 times 5. 28 will give us 4 times 7. 20 will give us 4 times 5. And 63 will give us 9 times 7. You break this down, you are getting square root of 16 times square root of 5 plus square root of 4 times square root of 7 plus square root of 4 times square root of 5 plus square root of 9 times square root of 7, as you can see here. This will give us 4 root 5. You simplify this, you get 4 root 5. You simplify this, you get 2 root 7. You simplify this here, you get 2 root 5. And you simplify this here, you get 3 root 7. Now you can see from here that some numbers under the square root sign, in this case, some of the numbers under the square root sign are 5, others are 7. So you group the 5 together, then you group the 7s together. If you are grouping them, you have square root of 5 plus, we have 4 root 5 plus 2 root 5, then you group the 7s also together, so you have 2 root 7 plus 3 root 7. So here we can see that the numbers under these square roots are the same. So you have square root of 5 here, square root of 5 here, so you can add what is in front. Here when you come here, you have square root of 7 here, you have square root of 7 here, so you can add what is in front. So you add for this part. So you have 2 plus 4 plus 2 root 5, then plus, when you come here, you have 2 plus 3 root 7. So 4 plus 2 will give us 6, so you have 6 root 5. 2 plus 3 will give us 7, it will give us 5, so you have 5 root 7. Now when you come here, you can see that this is square root of 5, this is square root of 7. Since they are not the same, you can't add, so you end here. Thank you for watching this video on addition of sets. Pick more examples and follow the same principles that we have used in this video. See you in the next video where we will tackle subtraction of sets. Bye bye.